Hi everybody, I'm Jennifer Alhaddad and this is my element project. It's for the element I chose is xenon. The reason I chose it is for a funny reason. It made me think of Xena, warrior princess, so I just went with it. Yeah, I have my helper right here. Okay, as you can see, it's xenon. Symbol for it is X, uppercase X, and lowercase e. It's pronounced xenon. Um, I wanted to do a poster, but I really wanted to do an actual model until I saw that it had 54 protons, 77 neutrons, and 54 electrons. So that would have been a really big model. So I decided to just do a poster instead. So obviously this is not 77 neutrons or 54 protons, but I did the best that I could. And it has 1, 2, 3, 4, 5 orbitals. And it's got, I think the most electrons on each one is on the orbitals is 18. It's a noble gas. And then facts about xenon is the atomic number is 54, as I stated earlier. The atomic weight is 131.293. It has a boiling point of 165.03 kelvins, which is the same as saying negative 108.12 Celsius or negative 162.62 Fahrenheit. It has a melting point of 161.36 Kelvin, which is the same as saying negative 111.7 degrees Celsius or negative 162.22 degrees Fahrenheit. Sorry, I had to do that because that was on our last test. So the converting from Kelvin to Celsius to Fahrenheit, etc. And then we have the density is 0.005887 grams per cubic meter. So that's the general information. Oh, it's the period number is 5 and the group number is 18. And again, it's a noble gas. So that's the basic information of the actual atom, what it's made up as far as, electrons, protons, and, basic information. So let's dig into the history. So this handsome gentleman is William Ramsay. And this gentleman right here is Morris Travers. Not that he's not handsome, but, William's a better looking guy. Xenon was discovered by the Scottish chemist, which is William Ramsay, and the English chemist, Morris Travers, in July in 1898 at the University College of London. Both Ramsay and Travers had already extracted argon, neon, and krypton from liquid air. They were gifted a new liquid air machine from Ludwig Mohn, who was a wealthy industrialist, and began to extract more krypton from the air. So they took the krypton and they kept performing distillations after distillation after distillation. They did, I don't know how many distillations they did, but eventually it got them to the heavier gas, which was xenon. So they examined this heavier gas in the vacuum tube, vacuum tube, and they saw that it emitted this beautiful, kind of like glowing light. So it was kind of like I guess for the late 1800s, it was kind of like a glow stick for them. They were like, wow, this is crazy. So they categorized it as an inert gas, and they named it xenon from the Greek word xenos, which is directly translated to stranger. But in 1962, and I didn't put his picture on here because he wasn't the discoverer. He was just, somebody who added some more info. His name was Neil Bartlett, and he proved that xenon was not an inert gas and that it could cause reactions and bond to form, compounds. So he disputed the inert gas, but they still categorize it as a noble gas. So, it's still a gas regardless. Sources of xenon is actually pretty rare. It's found in the Earth's atmosphere at about 1 part per 20 million, which right there is pretty rare. There are some mineral springs here on Earth that emit xenon, but they're also very scarce. Um, there's not a lot of hard evidence. There have been some discoveries that xenon may also be found in the Earth's core, where it's believed that it'll bind to iron or nickel. So that's how. So it's not found in its purest compound. I mean, purest form, purest element. It's actually in compound, connected with iron or nickel. So technically, it's not the actual element, but it's there. It's in the core. Uses for xenon. Right now, lamps use xenon to illuminate better than conventional lights and create a blue or lavender glow when subjected to an electrical discharge. Sometimes it's used in nuclear energy plants. There wasn't a lot of information of how specifically it's used in nuclear energy plants, but I guess I can speculate. I'm sure they probably use it for lighting and whatnot. It's used for filling television or radio tubes. I didn't even know that we still use tubes for television, but I could be wrong. Xenon ion, it's also used in silicon microprocessors. They're etched with xenon difluoride, so not the pure element, but a compound mixture. Xenon ion propulsion systems help keep satellites and other spacecrafts in orbit. That I did not know. I found that kind of interesting, that xenon plays a role in keeping our satellites orbiting the Earth. Xenon is also used to help manufacture a cancer treatment drug called 5-fluorouracil. I'm not sure if I'm saying that right, but that's actually in the UK. It's not in the United States, from what I read. So that's something that is being used for, in Europe for cancer treatment. I thought that was pretty interesting. Right now, current research that's xenon's being used for is the Xenon Dark Matter project. That sounded kind of creepy and mysterious to me, but basically they're using a liquid xenon detector to search for dark matter. And in all honesty, I didn't know what dark matter was, so I had to look it up. Dark matter is described as the invisible glue that holds the universe together. So, okay. I didn't know what to do with that, but, hey, people are out there searching dark matter. Pretty cool, I guess. And then this right here is nothing special. This is just my works cited. I can kind of scoot that up just so it's visible. Let me see. There it is. Kind of give you a good shot of where I got this. It's basically two websites. One, yes, it's got a corny name. It's ChemiCool. And the other is livescience.com. That one was pretty good. It had a lot of information. But, so that's pretty much it. My xenon element. Let me give you a close-up of my metallic pipe cleaner orbitals and my little green emerald electrons there. And again, I wasn't able to make an actual nucleus with the little puff balls just because it's flat, but I just did the best I could and just kind of use your imagination that there's a backside to it with the remaining protons and neutrons. We'll get imaginative here. But yeah, that's pretty much it. I don't know what else I can say about it. There's some cool image of what it looks like glowing. I know that's hard to see, but it's a dark background, and that bright whiteness is the xenon. And it says 131, which I'm assuming it's because they're when I was reading, I didn't put it up here. I probably should have, but there's 20 different isotopes for it. They're not very stable, but that could be one of them. Maybe that's why it has that number on there. It says xenon 131. Or actually, no, that's correct. That's the That's the atomic mass. I'm wrong. Ignore what I just said. Just forget it. But yeah, that's about it. Thanks, guys.